In this right triangle trigonometry problem, we're being asked to solve a triangle. To solve a triangle, you have to identify the lengths of all sides and measures of all angles. In this problem, we have to find the measure of angle A, angle B, and angle C are given. The length of side A, the side across from angle A, is missing. We'll have to find that. The length of side B, the side across from angle B, is given. And the length of side C, the hypotenuse, the side across from angle C, is also missing. We'll have to find that. We'll find a lot of the missing parts using the trig ratios based on right triangles. In any right triangle, if you're looking at an angle that's not the right angle, the sine of that angle is equal to the opposite side's length over the hypotenuse length. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. When I approach this problem, I'll consider angle B, and across from angle B is the opposite side. Across from the right angle is the hypotenuse, and the angle on the other side of angle B than the hypotenuse is the adjacent side. Let's solve this triangle. Again, to solve the triangle, we're going to have to identify the measures of all three angles and the lengths of all three sides. In this problem, we've been given the measure of angle B, 44 degrees. We've been given the measure of angle C, that's the right angle, 90 degrees. And we've been given the length of side B, the side across from angle B, is 8.9. We don't know, we're not given units here. I don't know if this is meters or centimeters or kilometers, depending on the context of the problem. So I'll just write 8.9 for the length of side B. The measure of angle A will be the easiest to find. It doesn't require trigonometry. In a triangle, the measures of the three angles always add up to 180 degrees. So angle A is 180 minus the measures of the other two angles that we know, 180 minus 90 minus 44, and that's exactly 46. Angle A is 46 degrees. We'll use trigonometry to find the two missing sides, side A and side C. The order we find these two sides in doesn't matter. I'll begin with side A, the side across from angle A. Again, when solving this triangle, I'm going to focus on angle B and label the sides opposite, adjacent, and hypotenuse based on angle B because that was the original angle that I was given. I could choose to focus on angle A, but I'll focus on angle B. And across from angle B, the opposite side is the side that's been given as 8.9. The adjacent side is side A, and the hypotenuse across from the right angle is side C. To find side A, I have to realize that I've been given the opposite side. I know exactly what the opposite side is, and side A is the adjacent side. So I'm going to have to use a trig function that relates opposite and adjacent. And if you take a look at the three trig functions at the top of the screen, you can see that the only one that includes opposite and adjacent is tangent. In fact, the tangent of any angle in a right triangle is the length of the opposite side over the adjacent side. So in this case, the tangent of 44 degrees is equal to its opposite side, 8.9, over its adjacent side, which is the unknown length of side A in this case. And at this point, I have an equation with only one unknown. I can solve this equation for A in two quick steps. The first step would be to multiply both sides by A. A times the tangent of 44 degrees equals 8.9. And that means that side A's length, if I divide both sides of the equation by the tangent of 44, is 8.9 divided by tangent of 44. Now the tangent of 44 is irrational, and this quotient will be irrational. I'm going to round these answers off to the nearest tenth. Depending on the context of the problem, you might have to be more precise than that, but 8.9 divided by the tangent of 44 is approximately 9.2 units. Side A is approximately 9.2. We have one more missing side, side C, and we could use the Pythagorean theorem to find side C now that we know side A and side B. That's somewhat of a bad idea in general because side A is not exactly 9.2. We were given side B as being 8.9, but side A is rounded off at 9.2. We would be better off and get a more accurate answer for the length of side C if we used trigonometry. That would only require the use of the 44-degree angle and the 8.9 side that we know exactly. Those were the given information. So I'm going to find side C using trigonometry. Side C is the hypotenuse, and side B is opposite of angle B that I know exactly. The trig function that relates opposite and hypotenuse is the sine. So I can say that the sine of 44 degrees is equal to the length of its opposite side, 8.9, over the length of the hypotenuse, which is the missing length for side C. I have an equation at this point that's very similar to the equation I had when I found side A. I'll begin by multiplying both sides of the equation by C, and then divide both sides by the sine of 44. This quotient is the approximate length for side C if I round it off to the nearest tenth. 8.9 divided by the sine of 44 to the nearest tenth is 12.8. At this point, because I've identified the measures of all the angles and the lengths of all the sides, I have solved the triangle. Note that this answer makes sense. It's not a 100% check, but this answer makes sense because across from the largest angle, 90 degrees, is the largest side. And across from the smallest angle, 44 degrees, is the smallest side. The angle measure that was in the middle is across from the side length that is in the middle. This triangle solves to angle A being 46 degrees, angle B is 44 degrees, angle C is 90. Side A, 9.2, side B, 8.9, and side C, 12.8, if I round off those side lengths to the nearest tenth.